Okay, good afternoon, Internet. Welcome to another NL Math Man Math Help stream. Hope social distancing is still finding you well as we carry on getting our learn on here. And we're on to a baker's dozen of my tutorials. It's pretty good, right? So if one of these was too small, hey, guess what? We've included an extra, so you got no reason to complain, right? That's right. Mm-hmm. We talked about Baker's dozens on stream already, I believe. Went over those briefly. You see the wonderful picture that I've got up for you today. Oh, isn't it sweet? Yeah, it's doing nice. That's a little tiny Flurry, a tiny Flurry there when she was a little bit younger here, and this little Smoky. Although he's not, I say he's a puppy there. He's probably what is he, a year old maybe at this point, right? So he's not as small. I do have pictures of him even smaller and even fuzzier. But yeah, that's him as a younger boy and a little girly. She's how old is she in this picture? I don't know. She's probably 4, maybe 5. 5 in this picture. Yeah, you can see her different color eyes there very clearly, right? That's the husky. It's the husky side showing through for sure. Take a sip of my delicious orange pico. Mm. Oh, the steam is nice. Cleanses the nostrils, rehydrates, and reinvigorates. Okay. So, without too much ado today, I'm going to jump into the math questions. Maybe I'll find more to ramble about as we're going through, as I usually do. So let me switch on back over then to my working display. Here we go. And we can see, oh, it's just two doggy butts. Two doggy butts in the picture now. Okay, I'll zoom out a bit. There we go. Now we can see them again. Okay, but I'm going to bounce over now to some questions from Prism Math Purple, or Prism Math Blue, sorry, rather, on stem and leaf plots. I know the page is a little bit blurry up there in the corner. Don't worry too much about that though, because all I really need from it are these numbers, right? And I'll show you how to do a stem and leaf plot. Now, Renetta, I know you asked about this one. Um, this is now similar to ones that we were doing yesterday as well. I believe I've done stem and leaf plots several days running now. So if you check the previous streams, you might see some more good detail on those. But I will gladly go over them again today as well. And this is the specific ones in Prism Math Blue where you had to do stem and leaves. Stems and leaves? No. Stem and leaf plots. There we go. Get a good position on my paper pad. Okay. So this is now going to be Prism Math Blue. Am I on screen? Yep. Prism Math Blue. And then what pages is this? This is 202. Page 202. And it's going to be stem and leaf plots. Now you do go on to see these again later. Yes, good morning, Renetta. Thanks for letting me know in chat that you're here. So yeah, I will go down through these ones. I'll also do a few from the next page as well, which are some more that you have to cover. And Esther, if you were kicking around anywhere, these are also, as you'll know, topics that you are working on right now as well. So this could be useful for some of the questions you're doing. Because like I've said a lot of times, right? These topics do keep coming back up. So question 1A, that's these numbers, is all those ones, right? So there's two different ways to do a stem and leaf, kind of. Well, there's only really just one. Sometimes people will tell you to do an unordered stem and leaf first and then an ordered one after. So that's what I'm going to do here first. So this is going to be my unordered, right? So what I'm going to do there. Now, sometimes it's not necessary to do ordered and unordered for a small group of numbers, but it can save you a lot of work when you get to really big numbers. Stems and leaves, Now, that's a nice cross-curricular, nice cross-curricular English one. It's not a stem and leaf plot. No, it's a stems and leaves plot, unless you only have one of each, right? You need the plural form. Anyway, so now I'm just going to start jotting them down in the order that I see them on here. So I do have 6, 7, 8, and 9 as my stems. This is the unordered one, so now I'm just going to go through in order. So it's a 74, an 84, a 91, a 68, 78. I put commas in between them. You don't have to, but I like putting commas in there. A 95, a 94, an 88, and an 82. Right? And that is all 10. Yes, there's 10 numbers in both. So this is our unordered stem and leaf, because you notice that these ones here are now out of order. So now I'm going to do an ordered one. And again, you needn't do an ordered and an unordered, or rather, you do need to do an ordered. You needn't do an unordered all the time, but if you've got a lot of numbers to deal with, then it's going to be super useful to do ordered and unordered. So here now, 68 is the first one, 7, and then it's 4, 5, and 8, because all I'm doing now is I'm reordering these ones here, right? So now I have 8, and that's going to be 2, 4, and 8. 9 is going to be 1, 4, and 5. Now we're almost done, almost completely done. We only need one more thing. That is a key. It is super important to have a key. Yesterday, actually, I showed a pretty good example of a stem and leaf where you really do need a key, because there we had like, if we had 6 bar 8 like this in the one we did yesterday, it would have been 6.8, right? So it would be super important to tell someone what it's going to be, even if it's just what we consider sort of the normal one or the most obvious one, where 6 bar 8 is equal to 68. We still have to draw a key there to indicate. And say if this was a 3-mark question, one of your full marks would be drawing out the key, right? So it's a super easy way to get a mark there. Just remember to put in an example. And it doesn't have to be the first example. I just always make it the first one, but it needn't be. Now number 2a is a really good one to go on to for my next stem and leaf plot, because it shows sort of another side case where you've got multiple digits. And now what do we pick as our stems? What do we pick as our leaves? Right? Because here now, are we seeing all those? Yes, okay. I'm zoomed in well. So we can see over all the way to the side. So there's question 2. Excuse me. So now I'm going to do an unordered. But what do I do? What do I do here? Like if I go ahead and just write the first digit as my stem, right? Because over here there's only one digit as your stem. Here there's one digit as my stem. If I put in a 1 as the stem, what are my leaves going to be? 0, 8, 3, 4, 5, 5, 4, 9, 0, 3, 3, 1, 4, 2, and 5, 2. I mean, look at that. Does that service any point? Well, I mean, this is perhaps technically a fine stem and leaf plot, but it's not doing any good for us whatsoever, right? Because the point of a stem and leaf plot is to represent a group of numbers in a more compact form. And this is not really any better than just having a list of them, right? So we're not going to do this, right? You will have to use your discretion, but a lot of the time when you've got numbers like this, what you have to do is look and see how they're clumped together, right? Sometimes 3-digit numbers, it will make sense to have the stem be the very first number and the leaves be the next two. But a lot of the time, or perhaps most of the time, your stem should be every digit except the last one. But it will all depend on how clumped they are. And for these numbers, they're all clumped relatively close together, right? They're between 103 and 155. So here we're going to go ahead and use the first 2 digits as the stem, because then the graph will look a lot more reasonable. So we've got 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, and 1, 5. Right? Now I know that there's no 11s and 12s in here, but we do still write them out. All right, we write them out and we just leave them blank alongside. Because again, part of the point of a stem and leaf is to show how the numbers are clumped together. And if there are stems, that we skip, we still write them on the left. We just don't put anything on the right corresponding to them. So here we have an 8 afterwards, and I'll cross them off as I'm going. Then we have a 4 here. We have a 5 here. We have a 9 here. A 3 here. Put my commas in between. A 1 here. A 2 here. And a 2 here. Okay, so that was our unordered. So I'll do my ordered one just over here. Stems and leaves. So 10, 11, 12, 13, 14, and 15. Right, and now I'm just going to put them in order. So it's 3, 8. And we don't put a 0 in here. You could strike it out if you wanted to, like that. That's a fine thing to do, or just leave it blank. It's going to be a 1 and a 4, a 2 and a 9, a 2 and a 5. And then our key will be 10 bar 3 equals 103. And again, right, important to have the key there. And I was always told to put a box around the key like so. Right? But that is how you will do stem and leaf. And that is mostly, those are mostly all the sort of edge cases that we'll see. The only other possible edge cases are involving numbers with decimals. I don't see any examples of ones with decimals on here, but I did do examples of ones with decimals yesterday. It's not really all that different. Right? Just the key would need to represent that there's going to be a decimal in the number once you're done. Okay, Renetta, I know you said you had to go early today, so I am going to be doing yours ones first, as you're seeing. If you've got any other questions about these, just drop in chat. Right? But I am going to go ahead and do one example on your next page as well. And I think, oh, this is good. This is good, actually. I will also do a stem and leaf plot because this shows, where do you get the key again? Oh, the key is just your first number. Right? Let me show you again. So on here, I picked 6 bar 8 to be 68 as the key for this one because my very first part of it, or just the first one I have down is this, right? And we know that the number it corresponded to is 68 because that was our number from up here in the set. Same as over here, I picked 103 because 103 is the lowest number in our set. It doesn't have to be the lowest one. It could be any of them. I just always pick the first one, right? So this one here is this in the key. Right? I'm going to do now, I said Prism Math Blue. This is going to be page 203. So I'm going to do 1B on here, and I will also do a stem and leaf plot along with it, and then I will show you how we get the mean, median, and mode partly with the stem and leaf. All right, so our numbers for 1B are 13.1, 13.2, 11.7, 15.2, 11.7, and 12.5. Now, one reason I wanted to show this one for a stem and leaf is because it's a really good example, like I said, of one where there's the other edge case that we haven't dealt with yet, which is decimals. So it's going to be my unordered. Now, again, we kind of run into the same issue as the last one. Whereas if I pick 1 for my first digit, if I pick 1 for my stem, then my leaves are just going to be, there's going to be a different leaf for each number. Well, there always is a different one for each number, but there's only just going to be the one category first. And we don't want there to be one stem, right? If there's only one stem, it defeats the purpose of making this diagram in the first place. So I'm going to pick the first 2 digits, and I see that 11 is the lowest and 15 is the highest. So I'll have my 11, 12, 13, 14, and 15 for my stems. Actually, you know what? Forget it. I'm not going to make 2 this time. I'm going to cut to the chase and have this one be my ordered one right at the gate. So this will be my ordered stem and leaf right away. I don't always recommend doing this, but there's only like there's so few numbers, only 7 numbers, right? So there's nothing in 12s. Oh, no, never mind. There's a 5. There's a 5 in the 12s. I should be crossing these off as I'm going. There we go. There is in the 13s, there's a 1 and a 2. And then there's nothing in the 14s, and in the 15s, there's a 2. Right. There we go. So never mind that squiggly bit. But now, Renetta, this could help answer your question from the last one. The key for this, I'm going to have 11 bar 7, which is kind of like what goes on over here. But that equals 11.7. Right? So this is an example kind of like what I showed yesterday, where the key is really important. Because here now the key lets us know that there is actually a decimal in between the stems and the leaves. Right? So now I can go ahead and find the mean, the median, and the mode. Well, first up, I'm going to do the mode because the mode is the easiest. Right? The mode is the most common value. Right? And here we see there's a 11.7 here and 11.7 here. So the mode equals 11.7. Okay, next I'm going to do the median. The median is the middle number in order. Right? So, to find which number is the middle, take n plus 1 over 2, where n is the number of numbers. Right? So just like when we're finding out the mean, we're going to use n to be the number of numbers in the set. So here, n plus 1 over 2 is going to be, well, how many numbers do we have? 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, yep. So it's going to be 6 plus 1 over 2, which is going to be 7 over 2, which is going to be 3.5. All right, so this is a good edge case as well because it's showing us what happens when our median comes out to be a 0.5th number. What we do now is we take the third and the fourth number and add them together. So if we get 0.5, we need the midpoint between two values, right? So the midpoint between two values, which two values are we taking? Well, we're taking the third and the fourth one. So what we're going to need here is actually 12.5 plus 13.1 over 2, which is going to give us 25.6 over 2, which is going to give us half of 25 is 12.5, half of 6 is 0.3, so that's 12.8. So here, it just so happens that the median, right, equals a number that's not even in the set. And that's totally possible, right? If there's an even number of numbers, your median is actually going to be between two numbers. Not necessarily always, because there could be multiple copies of the same number. But anyway. And now the mean is sometimes called the average, although it's not the average. These are all different averages, right? Add the numbers and divide by the number of numbers. And that's written as sigma, or the sum of n, divided by n. You don't necessarily need to remember that symbol. Just you might see it written that way sometimes. This means sum of. This is not the way you did it. You did use stem and leaf? Okay, sure. So for the median, you mean? Yeah, so to find the median, what you can do, the way it sometimes recommends, instead of doing this, it recommends you just cross one off from the front and one off from the back, and just keep doing that. So you would cross one off at the one lowest one's off, cross one of the highest ones off, then repeat, and then once you get down to the last two numbers remaining, then you average those two, right? But this here, this method is slower when you only have very few numbers like this. But say you had like, I don't know, 400 different numbers or something. You're not necessarily going to go through and cross one off at the front, one off at the back that many times, but you can use this to find out which number in order it's going to be. You're not going to have to find the median of 400 numbers. You'd use a calculator for that. But if you did, this would be a heck of a lot quicker than sort of the crossing off method. Although the crossing off method is totally fine. But so the mean then is going to be all the numbers added together. So I'm going to write out the full thing here. So mean is going to equal 11.7 plus 11.7 plus 12.5 plus 13.1, 13.2 plus 15.2, right? And that's going to be divided by 6 because that's the number of numbers that we have. So then I'm going to, oh, the heck did I put my friend TI-84? Oh, there he is. There we go. Lieutenant Commander Data over here. My math robot. 11.7 plus 11.7 plus 12.5 plus 13.1 plus 13.2 plus 15.2. There we go. That's 77.4. 77.4 over 6. And that's going to equal 12.9. Okay, so for this set, we see the mean and the median worked out to be about the same. And that'll be true for a lot of sets of numbers. And generally anything that's normally distributed, which we actually don't really talk a whole lot about. But basically you would expect for a set of numbers for the mean and the median to be pretty similar. The mode, unfortunately, is kind of just random. Like the mode, I've mentioned this a dozen times, but the mode is very rarely a good measure of central tendency. But it is still important to know that the way you get it is just finding the most common value. There's one more part of central tendency, and you're not asked for it on this page, but it's the range. Range is just the highest value minus lowest, right? So here, range would equal 15.2 minus 11.7, right? And that's going to be, what is that, 3.5? Right. So those are, sometimes you'll see them ask for range. Renetta, you're not asked to do that on the page you're on right now. But when you see this topic again, and you will, range is going to come up as well. Okay, so I hope that answered your questions on that unit fairly well. Let me know if you have any other questions about the same topic. Or any other topic, really. But I know you did say that you had to go early today. You mentioned that you're working though. I don't know. Boy, oh boy. Yeah, make sure to stay safe. Stay safe as best you can. It's you know, it's a tricky one out there. So I'm going to pop over now to some of the other topics that I mentioned I was going to cover today. Let's see here. Now, this next activity that I'm going to be doing, this is one that Ashley submitted, but it's got a lot of really useful stuff on there for the same kind of topics that Esther is going over as well. Because, no, not the ones that Esther's going over right now, actually, no. No, the ones you've gone over, she's gone over before. This one is actually kind of similar to the ones Renetta just got through, actually. So, yeah, even though it's not for the courses that people are that everybody is doing right now, it can still be very useful to people. Um, oh, okay. So what is the surface area of a cube with side length 2 centimeters? Hold on 1 sec. Twitch there. I just have to got to respond to something quickly here. Okay, okay, we're back to it. Just had to send off a quick email response there. Uh, okay, so this is going to be Math 1102A, and it's Unit 3 review. Okay, I'm just going to go down through some of these ones. Some of these are going to be quicker than others, but they're all, they're all good questions in a sense because they're all ones that you guys have to know. Okay, so for the first one here, for question 1, and that is, yep, that is one of the ones I wanted to go over. What is the surface area of a cube with side length 2 centimeters? Right? But the thing is, you have to remember that when we're doing the surface area, we're not looking for the volume, so we're not looking for them all multiplied together. And we're also not looking for the distance along the edges, right? Because that would be sort of like the total perimeter or the edge length. What we are looking for is just the area of each face added together, right? So there's a approximation of a cube. We've got 2 cm down, 2 cm across, and 2 cm there. So the height, the length, and the width are all 2 centimeters. Right now it's asking for surface area. So we know that surface area is the area of all faces added together. Right? So if I said the area of a face here, it's going to be, well, what's the area of each of these? Well, it's a cube, right? And by definition, we know that a cube has all sides the same length. So it's going to be 2 this way, 2 this way, and 2 this way. So the area of one face is going to be 2 times 2, which is equal to 4. And now how many faces are on a cube? Well, let's find out. Right? Super easy. Of course, there's 1, 2, 3, 4, 5, 6. There's always 6 faces on a cube, on any, standard D6, a 6-sided die. So not 9. No, it's actually 6. There we go. See, it's even marked underneath. So the surface area is going to be equal to 6 times 4. So the surface area is going to equal 24 centimeters squared. And it is important to write in squared for these ones because it is the area of the faces. Right? An area is in squared centimeters or squared meters or squared whatever. Okay, number 2. What is the approximate area of a circle with diameter, what does that say? 8 feet. Okay? So it's important to know here now which formula you'll be using. Now you do have a formula sheet with this activity, and this is the same formula sheet that you're going to get on the test for this unit, but this is how it looks, right? So an important part is being able to read this document over here as well. Now we're trying to find the area of a circle. Now, where do we see those? There it is, area circle. It's a little bit small to see up there in the corner. So let me zoom in a bit. Zoom in, zoom in, zoom in. There we go. That's a bit easier to see. We can see that the area of a circle is equal to pi r squared. Right? So we know that that is the formula we're going to have to use. Area equals pi times radius squared. So now if I bounce back over to the activity over here, we see now, what is the approximate area of a circle with a diameter of 8 feet? Oh, well, we don't have the radius, we have the diameter. What do we do? Well, your formula sheet, thankfully, even tells you that diameter is equal to 2 radii, radiuses, 2 radii. And then down here, they even rewrite it for you. Look at that, right? Like if I made this sheet, I would not include the second form of it. Not a chance. I would just give you this one and be like, deal with it, right? But no, they went the extra mile and they even rewrote it in terms of R as well as in terms of D. So we know that the radius is equal to the diameter over 2. So the radius is equal to 8 over 2, or the radius is equal to 4. Now we can just go ahead. Geez, I'm hiccuping. Now we can just go ahead and figure out the area. Area is going to be equal to pi times radius squared, and it's super important, super duper important, and it's a mistake that loads of people make loads of times. But this is squared when it's area. It's a 2 up in the corner, not a 2 down alongside. So you're not multiplying by 2, you're multiplying by the same number twice. So it's actually pi times 4 squared, which is going to be pi times 16, which is going to be exactly 48. Pi times 16, 50.3. 50.3, and that is feet. So feet squared. 50.3 square feet. Okay. Question 3 next. What is the area of the garden shown? The area of that garden. How are we going to find that? Well, we'll zoom in on this guy a little bit. There we go. So that's the shape that we have. Now it's super important to remember what they're asking us for here. They're not asking us for perimeter, which means they're not asking for the distance around the outside. What they're asking for is the area, which means how much space the shape takes up. So in order to find the area, there are 2 different ways that we can do it, right? We can either split it into several shapes, and we can find the area of each of those, or we can take it as an overall shape and subtract the missing bit. Either of those is totally fine. But let me copy out the rest of the measures that we have here. That's 4 meters, that's 3 meters, that's 4 meters, 6 meters, 10 meters. Okay? And we know, of course, we know now that this one here is going to be 3, and this one here is going to be 6 meters, right? Because they're directly across from each other, even though we weren't told those. So now, there's 2 separate ways to find the area. Well, kind of a whole bunch because we can split it in different ways. But I'm going to split it down through here and then down through here as my first option. Then after I'll show you a different one. So we've got sort of A1 here, I'll call this. Area 2, I'll call this. And area 3, I'll call this one. Okay, just so we have it split into 3 separate chunks. So in area 1, these are all rectangles, so it's just going to be length times width, right? So we have to make sure that we're taking the length and the width of the full shape. So here it's all the way out around this way. So it's going to be 2 on the top and 6 on the side. So 2 times 6. So A1 is equal to 12. 2 times 6. A2 then is going to be this one here, which is this section, right? We know it's 4 meters across the top, so there's going to be a 4 here. But what is it in the other direction? How can we find that, right? Well, we know this full side is 6, and we know that this part here is 3, so this part that's left over has also got to be 3. So that part is going to be 4 times 3, so A2 is also going to be 12, just so happens. Then area 3, or the third shape, is going to be this one over here, right? Which is going to be 4 times 6. So A3 is going to equal 24. Then A total is just going to equal A1 plus A2 plus A3, which is going to equal 12 plus 12 plus 24, which is going to equal 48 meters squared. Okay? And that is one way to go about solving this one. Another way to do it, right? And you don't need to do both of these, you only need to do one. But another way to do it would be to imagine this bit here that's taken away. So I'm going to color that in red. But imagine that that was there, right? And imagine, say, that the outside, I'm going to do the outside of the full shape now in black, say. I'll draw an extra black line out around the whole outside. Just to really make it clear what I'm doing here. Right? So the area of the outside is going to be the black one out around all the outside there. So that is going to be 6 times 10. 6 times 10. The area of the outside is going to be 60. Right? And then I'm going to call this one the area of the gap, or the area of the part that's left out. That one is going to be 3 times 4. We can see that there, which is going to be 12. Right? So then I'm going to go to get, I'll do it in blue now so we can see that it's different. So now the area total is going to equal 60 subtract 12, which is going to be, again, 48 square meters. So there's several different ways that we can do ones like this, but we do need to know that what we're finding is the area. So we're either going to chop it up into small pieces, like I did here in green, or we're going to find the outside area, say what it would be if no pieces were missing, and then subtract the area of the pieces that are missing to get our total. Either of those are totally fine. Okay. So I'm going to carry on then. Math 1102A, Unit 3 review. Right, and yeah, I'm going to do number 5 next. So let me just scroll down a little. An image of an auk. Hey, there's some poems about the great auk. Image of an auk measures 3 inches by 5 inches. Now, I'm not saying hawk with a Newfoundland accent. Dash big auk, my son. Jesus, boy. Look at the size of that auk. Oh, look at the auk over there, look. Oh, look at that, look. Image of an auk measures 3 inches by 5 inches. Suppose the image was enlarged to 5 times its length and 5 times its width. What is the new area in square inches? Okay, so we're doing 5 times 5 times. So let me zoom on in, zoomerino. Now over here, we see that the area was 3 inches by 5 inches. But both of these are going to be 5 times as big as they were previously, right? So I'll just draw out a diagram here of a, well, a really brief diagram. Okay, and it's going to be 3 inches by 5 inches. Now you might be tempted, because it's asking us for the new area. We might be tempted just to go ahead and find the area and then multiply by 5, right? So the area of the original is equal to 5 times 3, which is 15. And then 15 times 5 is equal to 75. Is that what we're doing? No. No, that's not what we're doing. We're not doing that at all. Because all that would do then, all that would do is multiply one of the dimensions by 5. It's actually multiplied by 5 twice, right? So it's actually going to be times 25. But let me show you over here now, if you can see what I'm going to do over there, right? So I'm going to draw out a new one, and I'm going to do both of them by 5. So 5 times 5, this one's going to be 25 now. 3 times 5. This one's going to be 15 now. So the area of the new one is going to be 25 times 15. So it's going to be 375. Yeah, 375. Look at that. 375 inches squared. Okay, so that is 5A. What is the new area in square inches? 375. What is the new area in square feet? Now, this is an example that I like to do a whole lot because people often find this one to be tricky. Because people often say, oh, well, I know that there's 12 inches in a foot, so if I divide by 12, I'm going to go from square inches to square feet, right? Unfortunately, no. No, it's not, because there's a different conversion factor when you're converting area. You actually square the conversion factor. And I'll show you why over here. This is just an example of why you've got to square the conversion factor. So this is 1 foot by 1 foot, right? 12 inches by 12 inches, right? Those are the same thing, right? 1 foot is 12 inches, 1 foot is 12 inches, right? So 1 foot by 1 foot is going to be 1 foot squared, but 12 inches by 12 inches is not 12 inches squared. That's actually 144, right? So we know that 1 square foot is equal to 144 square inches. So if we want to get from square inches to square feet, we actually got to divide by 144, right? So it's going to be 375 inches squared times 1 foot squared per every 144 inches squared, like that. Our inches are going to cancel. We're going to be left with 375 divided by 144, and I'm absolutely not doing that one in my head. That is going to be 2.6 square feet. So the answer then for 5B, asking us what's the new area in square feet? New area in square feet is going to be 2.6. Let's see, I'm going to do question 7. Or sorry, question 6. I am going to do question 6. Mr. Davis is building a new house and has quoted a price. Let me zoom out. Oh, yeah, okay. Okay, this is a good one, yeah. In square feet, calculate the area of the house. Now, unfortunately, yeah, boy. Unfortunately, the version I sent you, Ashley, or the version I sent it to any students, uh, it's a little scuffed over here. It's tough to pick out what those are. So I'm going to go ahead and draw that one out a bit, right? So we'll call this 6A. And go ahead and draw out sort of an approximation of this shape. All right, I'm going to draw it quite big, as we're seeing. There we go. Should be more than enough room to get all of my values on here. So this one here is 25 feet. This one over here is 20. So no across here is, what the heck is that, 24? That looks like a 24. What do you think, TwistJet? I'll call it 24 feet. Down this other side, is that 48? Boy, that's got to be 48, right? 48 feet and 62 feet. Tell you what, that's the values I'm going with. Whether those are the right ones or not, that's the values I'm going with. Okay? So this one is a good question because it's an example of the same sort of stuff that I've been doing recently in a whole bunch of courses, but this one is a little bit more complicated because there's a lot more steps that we have to find out yet. Right? So again, there are two methods to solve these ones. There's an addition method and a subtraction method. I'm just going to go ahead and do only one of those for here, and I'm going to do the addition method, the one that I've been showing first. Now, you are totally capable of doing a subtraction method here as well. I'm going to go ahead, I'm going to call this, let's see, I'm going to call this area 1, this area 2, and this area 3. Okay? So then area 1 then is It's going to be 24 across this way, because we can see that. And it's going to be 20 down here. So it's just going to be 24 times 20, which should be 480. 480 square feet. Okay? Area 2. Area 2 is relatively easy as well. It's this area over here, right? It's 62 across the bottom. But what is it down this side? How can we find that? Well, we know that this bit is going to be this full 48, subtract this 20, right? So it's going to be 28, right? And I'm not going to do that one in my head. 62 times 28, 1736. So that's 1736 square feet. Okay? The last piece that we need to find is going to be A3, or the third area, which is this triangle over here. Now that's the more difficult part, but it's not that much more difficult, right? Because we know the height of the triangle from here up is going to be this same 20. The area of a triangle is a half base times height, which is going to be a half times some number, the base, times 20 for the height. Now how are we going to find that base? What's that? Well, we know that the base of the full shape, the bottom of the full shape across here is 62. We know that this is 24 and this is 25. 24 and 25 put together make 49. And we know 62 minus 49 is 13. So that's how we know, right? So it's going to be 62 minus 24 and minus 25. That's going to equal 13. Right? So a half times base times height. Here it's going to be a half times, well, half of 20 is 10. 10 times 13 is 130. So that's 130 square feet. So then the area total is just going to be the three of those added together, 480 plus 1736 plus 130. And that is going to be 2346. 2346 square foots. There we go. So that is 6A for us. 23 square feet. That is the area. Area meaning how much space it takes up. According to the contractor, what will the cost be to build the house? Okay, well, how are we going to find that? So contractor quoted a price of $55 per square foot, right? So if it's $55 for every 1 square foot, how are we going to find out what it's going to be if there's 2346 square feet? Well, we're going to multiply, right? So then 6B, right? It's going to be 2346 feet squared multiplied by $55 per square foot, right? And that then is going to equal, we're going to have the feet on the top cancel with the feet on bottom. The only unit we're going to have left is dollars. Now, dollars is an odd one for units in that, in English anyway, the dollar sign is put usually in front of the number, but you can put it after for these purposes. I don't mind. Some currencies are always written afterwards in some countries, right? It does make it a touch simpler for the way you would write math like this, but really, it's not that big a deal. Right, so he is going to be looking to pay $129,000, $129,30. That's a hefty chunk of change, for that property. But I suppose it is a over 2,000 square foot house on the main level, right? So, you know. Although I suppose $129,000 is cheap for a house, right? It's a lot cheaper than mine. But that's to get one built. You gotta buy the land and stuff too, right? So, you know, have one build, have one built. My goodness, what sort of grammar do I have? My grammar would not be very proud of my grammar. My grandmother was a teacher, so once upon a time, way back when, she went to Munn when it was still called Memorial College. You know that? Like years and years ago. Okay, so calculate the surface area of the following cylinder. Oh, oh my goodness. I just noticed that. I just noticed that. I marked that wrong on Ashley's one because she put a question mark down, but there's no numbers. There's no freaking numbers here. Now, Ashley, if you're watching, I apologize for marking that one wrong. But in my defense, the review sheets are actually not counted for marks. So yeah, this one. How in the world? How in the world? Okay, never mind. We're going on. We're going on to number 8. We're going on Twitch chat. We're gonna we're gonna get there. Okay. So, see, I tell you what. I'll tell you what. Instead of going on to number 8, I will show how to do question 7. Imagining imagining if there were numbers there. And I'll just fill some numbers in because it is important to know how to do these questions. Okay? So Ashley, if you're watching, apologies, but in my defense, it didn't matter anyway, right? Kind of. Very kind of. Very kind of. Um, Unit 3 review. Okay? So then question 7. Well, we're looking for the surface area of a cylinder. I think the surface area of the following cylinder. Okay? So I'm just going to draw myself out a cylinder over here. That across the bottom. And then imagine this was slightly circular and not very clearly an oval, but that will be the top, right? So let's say then that the radius, so radius equals, I don't know, 6, and the height is going to equal, say, 12. And that'll be centimeters. Okay? So imagine that you had those and you needed to find the surface area. Well, the surface area of a cylinder, and I do believe that comes up in, oh, okay. Now that does come up in question 10, actually. Tell you what, instead of doing question 7, there we go. That's the way to do it. Let's say I'm doing question 10 instead. Good, good stuff. Okay, crisis averted. I didn't have to make one up off the top of my head. I could just go ahead and do this guy. So here the radius is 5 and the height is 22. And that's meters, not centimeters. So don't mind me. I got there in the end. I found a useful one to go over anyway. Okay. So the surface area. How do we find the surface area of a cylinder? Well, and I'm going to break down why each of these pieces are what they are. Right? The surface area of a cylinder is going to be 2 pi r squared plus 2 pi r h. Now, why in the world is it like that? Well, this is the top and bottom circle, right? The top and the bottom of the cylinder is this term. Because we know, right, that the area of a circle equals pi r squared. That's a bit of an aside. We know that, right? So if there's 2 circles, one on the top and one on the bottom, that's why there's a 2 here, right? And then over here, this is the sides, or what we call the lateral area. Or the lateral area on the sides of the shape, right? Now, how do we find a lateral area? Well, let me grab a little piece of paper here. Tell you what, look, that's my stream start soon from yesterday. See how I had like try to do the text a bit different every day. Look, and it's pointing to my little muddy buddies that were on stream yesterday. But if we take a cylinder, say imagine this was tight together so it forms a cylinder like this, right? And this is the sides of the cylinder. If we were to cut the cylinder and then unroll it like so, what are we left with? Well, we're left with a rectangle, right? We can see that it's a rectangle after we're done. And what are the dimensions of that rectangle so we can find the area of it? Well, let me roll it up again and then unroll it just to see. Roll it up again. right? This side, this is the height, right? So the height is just one of the sides of the rectangle. So that's easy. That's easy enough, and that's why we see an h over here. But why the 2 pi r? Well, we do know that the, oh, where the heck did my black pen go? There it is. We know that the circumference is equal to 2 pi r, right? That's another sort of aside that we have over here in a bubble. So the area of a circle equals pi r squared. The circumference equals 2 pi r. So 2 pi r, if we look at a cylinder like so, 2 pi r is the distance around the end of the cylinder, right? It's the distance around this circle. And if we unfold it, the distance around that circle becomes one of the sides of the rectangle. So that is why this is here. 2 pi r is the circumference of the circle times h, which is the height. Right? So now, if we want to find the surface area of this guy, we can just go fill it in, right? But what? But what? Look at this over here. It says calculate the surface area of the portion of the tank which needs to be painted. Hint, the bottom does not need to be painted. Well, what the heck does that mean? So we only need the top circle, not the top and bottom. Okay? So then the surface area is going to equal pi r squared plus 2 pi r h. There's no 2 here because we don't need 2 of these. We only need 1. So then I'm just going to go and fill these guys in. So the radius we were told is 5. So that's 5 squared plus 2 pi, 5, and 22. So I'm just going to go ahead and get these ones. So it's going to be 25 pi plus 2 times 5 is 10. 10 times 22 is 220. 220 pi. So we add those together, that's going to be 245 times pi. And I like to leave it what we call in terms of pi up until the very end, if I possibly can. So 245 pi's is going to equal 769.7. 769.7 meters squared. Okay? It's an awfully big tank. 22 meters high. My goodness, 22 meters high. That's 66 feet high. Or more than that, like 70 feet high. A 70-foot high tank. Boy, you're not fooling around. That's a good that's a fuel stockpile for the ages. That's what that is. Okay, so now I've got just a few more that I want to explain on here. Let's see now. I haven't been going for super long today, but unless anyone has any other questions, after these ones for Ashley, I'm going to end for the day for the stream. So if you have any questions, if you're in chat and you've got anything that you want me to cover, please let me know shortly. All right, because I'm only going to be on for maybe another 10 to 15 minutes doing these ones. So this is Math 1102A Unit 3 Review. Unit 3 Review like so. Perform the following conversions. So 504 inches squared equals some number of feet squared. Now let's look back over to the formula sheet that you're given for this unit. And let's see here what we can use. Well, here, right, they actually tell us. They actually tell us what conversion factor to use for feet squared to inches squared. That's right here. 1 foot squared is 144 inches squared. Right? So we know that if we have 504 inches squared, right? We can figure the answer out here in several different ways. but it's 504 inches squared. Now I'll do the cross multiplying way because actually that's what I've been showing you in your courses, and I from your notes I think that you're getting that method, so I'm going to keep reinforcing that one. 504 inches per some number of feet squared, right? But we know that our conversion factor is 144 inches squared per 1 foot squared. Okay? So now we can go ahead and cross multiply. Right? So this is just a different method that we can, or the method that you've been seeing all along. So on the left, we're going to have 504 times 1, and on the right, we're going to have 144 times x. Then we have the divide to get rid of this 144. We're going to have 504 divided by 144 equals x. And now 504 divided by 144 is going to equal 3.5. 3.5 equals x. So the answer to 8a, 3.5. Okay. I'm just going to go down through a few of these ones. Let me scroll on over. 1 meter squared equals some number of centimeters squared. So 1.2 meters squared. Now let's go back to the formula sheet again and check and see what they give us for that. Oh, well, look at that. 1 meter squared is equal to, they tell us right there, 10,000 centimeters squared. Easy, right? So what I can do is 1 meter squared multiplied by 10,000. 10,000 cm squared per every meter squared. And that now, the meter squared is going to cancel with meter squareds, and I'm just going to have 1.2 times 10,000, which I'm going to have the 1 and the 2. That was a 3. That was a 3, Peter. The 1 and the 2, and then we're going to move 4 places to the right. 1, 2, 3, 4. Fill those in with zeros. There we go. 1.2 is going to be 12,000 centimeters squared. Pop back over to the review sheet. Right, so for E, I'll go ahead and do E next. E is going to be 6.7 feet squared. And now we're going to multiply it to get it into inches squared, right? Times 144 inches squared per 1 foot squared. Feet cancel with feet. We're left with 6.7 times 144, which is going to be 964.8. 964.8 square inches. And now I'll do F. I'll do F as well. This one we start off with 11.5 yards squared, and we want to get those into feet squared, right? So just to pop on back to the formula sheet over here, hey look, we've got one. We've got one right there. It's even, we don't even have to derive it. Okay? We've got a yard squared equals 9 feet squared. So that's going to be multiplied by 9 feet squared per 1 yard squared. Right? Because we know the same units that we're using are the ones that have to go on the bottom. So yard squares are going to cancel with yard squares. We're going to get 11.5 times 9. 99 plus 4.5 is going to be 103.5. 103.5 feet squared. Okay, so that is that's all we have to do then for question 8, is that sort of thing. Okay, question 9 then is calculate the surface area of the rectangular prism, which is this guy here. Okay, so for question 9, I'm going to draw out the diagram. God, I'm so hungry today, I swear to God. I just can't, I don't know, being home all the time, man, oh man, feels like I'm eating loads more than I normally would. The worst thing for me too is like I'm a good cook. I like cooking and I make tasty stuff a lot. And then I just got like I'm constantly just making more bowls and plates and trays of tasty food. Boy, oh boy. How are you supposed to stop yourself from eating all the time when you're just home? Anyway, the travails of the travails at the home office, I suppose. Constant supply of food. Boy, it's tough. So all we're doing here now is we're finding the surface area, right? So the surface area of a rectangular prism is just going to be all the individual faces added together. And there's six of those, right? But there is a formula that we can use to get there a bit quicker. And let me see if your formula sheet gives you this one. And it does. It does. It's right there. Look at that. Right there, your formula sheet gives it to you. See? Man, that formula sheet is super kind. Like I would not give you this formula because this one you should be able to get just from thinking about the situation, right? So if this is we'll call this the L, this the W, and this the H over here. But the surface area is, well, this first side here on the front, this is going to be length times height, right? That's this face here, the one in black. But there's two of them, right? Because there's the one in behind as well, right? There's the one back here. And then we're going to add, because we always add with these. Now this side over here, this one that I'm going to do in blue, that one is going to be width times height, right? Because you can see it's width this way and height this way. And there's going to be two of them as well. And then we're going to have this one, the top one, right? So there's going to be two because there's the top and the bottom. And these ones are length times width. So what's really, really, really important here is to make sure that you have all the three combinations that are possible. Because you only use two at a time, right? It's length, height, length, width. So you've got those three combos. And then those are the ones that we're going to be adding together here. So this is going to be 2 times length is 14.6 times height is 2.8 plus this one is going to be 2 times 6.2 times 2.8 and plus this last one is going to be 2 times 14.6 times 6.2. Now all we got to do is go ahead and crunch those numbers. Just add them together. 2 times, oh, it would help if it was on. 2 times 14.6 times 2.8 is going to be 81.76. Then we're going to add the next one, the blue one, is going to be 6.2 times 2.8 times 2. That's 34.72. And then the last one is going to be 2 times 14.6 times 6.2, which is going to be 181.04. I'm going to go ahead and add those guys together. (297.52 centimeters squared). There we go. So that's all you got to do for that one. Yep, and then well, the last one is relatively straightforward. So I'll do that one as well on here. Question 11. Yeah, that'll be it for today after I finish this one. So again, if you're in chat and you've got any sort of questions for me, let me know shortly because we're probably only 5 minutes out at this point, unless I get something else to do. So we've got a rectangle here that's 7.5 inches in that direction and 22.6 inches in that direction. And of course, the area of a rectangle is just length times width. So here the area is going to be 22.6 times 7.5. Definitely not going to do that one in my head. 22.6 times 7.5, 169.5. And that's square inches. Okay. Now if I scroll on over, there we go, part B. Now, do I have a stencil here for a circle? I sure should. I should have some coins. Oh, my coins appear to have vanished. Tell you what I'll use. I'll use this multivitamin bottle because I, like a responsible adult, taking multivitamins because you never know. My diet is really good. Like I was just saying, I cook a lot and I cook for myself a lot. But of course, the variety of foods I'm eating is not quite as good now over thanks to not getting groceries very regularly. So perhaps I'm eating, more pastas and rices and a heck of a lot and more. Well, I'm eating a lot of canned tomatoes and frozen broccoli and stuff, so that's all good. But a lot less, say, lettuce or other fresh leafy greens. Not getting that so much. But anyway, a nice multivitamin takes care of all that. So here we've got, oh, we don't have a radius, we have a diameter. We have a diameter is equal to 3.8. Remember, the diameter is equal to twice the radius. So 3.8 over 2 is equal to the radius. So the radius is going to be 1.9. Right? Then we have to know that the area of a circle is going to be pi times radius squared. So in this case, it's going to be pi times 1.9 squared, which is going to be 1.9 squared is 3.61 times that by pi, and we get 11.34. 11.34 feet squared. 11.34 square feet. And there we go. Okay, good stuff. That is the entirety of the 1102A Unit 3 work that I wanted to go over today. So Ashley, I hope that helps. Yeah, if you're watching this in the future, hello, hello, future Ashley, and I hope that did help. Okay. Well, we are a little bit early. I'm just at the hour and 15 today. Not going to do any sort of special features on the just randomly on weekday streams, at least not yet anyway. My internet has been stable at this relatively low bit rate that I have picked, but I don't think I'm going to be able to squeeze out enough bit rate to do any more, I don't know, visually demanding streaming. This might be, me sitting here chatting might be about all we do. But yeah, just as a reminder, this Friday is Good Friday, which means this is the beginning of the Easter holidays here. I will not be streaming this Friday. Yeah, and next week we are off the whole week. I might pop on to stream just for fun during next week, just to keep my Monday to Friday sort of schedule going, because I know not every place in the world even has an Easter break. Some places do a spring break, right? So I might log on just for some fun, but we won't be expecting work in, of course, because it is just a normal holiday, like any other school holiday, right? So, your funding agents won't be expecting you to get credits in for that week. Effectively April is just a week shorter than other months, right? Because of the Easter holiday. Yeah. Yeah, so I won't be necessarily on next week, though I might be. I might be around just to have some fun, maybe to play some games. Like I mentioned before, for me, unlike most streamers, for me the game part is like the disposable part. That's just entertainment. That's not the work part. So for the record, whenever I do game streams, they're going to be ephemeral. Like they're one and done. Like there's no videos saved of any of my game streams. It's just going to be it's just for the moment. So maybe I'll even get some music playing or something because I'm not going to save the VOD anyway. But anyway, I think I'm talking just to myself here now. But thanks for sticking with me, folks, for another math stream. Again, please do submit questions if you have any. And yeah, have a great rest of your day. Stay safe, and I hope to see you again tomorrow.